right. So we've talked about balancing equations, and we've talked about the types of equations, the five types. So now we're talking about chemical reactions, how quickly they react to each other. The products are formed from the reactant. So some reactions are quick and others are slow. So rusting takes months and years. It's a chemical reaction. Combustion takes no time at all. The area of chemistry that studies the speed of reactions called kinetics. The speed of the reaction is called the rate. The rate of the reaction is measured at how fast reactants are changed into products in a certain amount of time, usually seconds. Reactants A and B, A plus B yields product AB. We've seen that. That's a synthesis reaction. But collision theory helps us explain the reaction rates. This is an introduction to collision theory. It states that the chemicals must react, they physically have to collide. A and B must, in order to react, they must bump into each other. During the collision, bonds in the reactants are broken and bonds in the products are formed. The rate of the reaction can be increased. The collision theory states that as the number of collisions increase per second, the rate of the reaction also increases. There are four factors that can increase the rate: temperature, concentration and pressure, surface area, and catalysts or inhibitors. Increasing the temperature increases the rate. When temperature increases, the reactants have greater kinetic energy, they move quicker and collide with each other with more force. This increase increases the chances of successful collisions. Low temperature, low kinetic energy. High temperature, high kinetic energy. Concentration, increasing the concentration increases the rate of the reaction. When concentrations increase, there are more reactants present in a given volume. This increases the chance of collisions. Low concentration, low chance of collision. So you see there's A's and B's, but they're spread out, not as many. High concentration, higher chance of collision. Pressure. Increasing the pressure increases the rate of reaction. When the volume of the container is decreased, there is more reactants in a smaller space. This increases the chance of collision. Low pressure, low chance of collision. So if we squeeze it, make the space smaller, there's a higher chance that there will be collisions. Surface area. Increasing the surface area increases the rate of reaction. When the surface area of the reactant is increased, crushed into a powder from reactants, molecules are exposed to the other reactants. This increases the chance of a collision. Low surface area, see all the A's are bunched together and the B's can only hit the outside. So if we break them apart, if we break A apart, there is high surface area and high chance of collision. So it doesn't just hit the outside, it can hit from all sides. Catalysts. Catalysts increase the rate of reaction. Catalysts increase the rate of reaction without participating in the reaction. Catalysts work by changing the way reactants combine. This increases the chance of collision. A and B, lack of catalyst, lower chance of reaction. Presence of a catalyst, higher chance of collision. Inhibitors. Inhibitors decrease the rate of reaction. They are like catalysts that they don't participate in the reaction, but they prevent the reactants from colliding with each other. The decrease of chances of collision. Presence of a catalyst, higher chance of reaction. Presence of an inhibitor, lower chance of reaction. Kind of blocks those sites so they can't get in there. Table below summarizes collision theory. Factor: temperature. Reactants have greater energy, move faster, and collide more often and more force. Concentration: more reactants present in the given volume, making collisions more likely. Pressure: the reactants are crowded into smaller surface, making collisions more likely. Surface area: more of the reactant is exposed to other reactants, making collision more likely. Catalyst: changes the way reactants combine together and make more successful collisions. And inhibitors prevent reactions from colliding, making less successful collisions. All right, we're going to stop right there. Thank you very much.